A boat traveled upstream a distance of 90 miles at an average speed of v minus 3 miles per hour, and then traveled the same distance downstream at an average speed of v plus 3 miles per hour. If the trip upstream took half an hour longer than the trip downstream, how many hours did it take the boat to travel downstream? So we have a rate question, and we got two legs to our trip. We have going upstream, and that means we're going against our current, and then we got going downstream. So we are going with the current. When we are going upstream, we are going a rate of v minus 3 miles per hour. When we are going downstream, we're going at a rate of v plus 3 miles per hour. Both legs of our trip are 90 miles. And then we know our trip upstream took 30 minutes longer. And so if we are putting everything in hours, if our time t for going downstream is t, and that is what we are solving for, then our time to go upstream is going to be t plus 1/2. Okay, and so we should be able to do this because we got two equations. Rate times time is equal to distance, so v minus 3 times t plus 1/2 is equal to 90, but we also know v plus 3 times t is also equal to 90. So we can set these equal to each other. Now, is there something else we should be doing? Because if we do that, we're not going to be able to solve from that one equation. We're still going to have a v and a t, so we'll have to substitute back again. But I don't see anything, a better alternative. So let's just say, so v plus 3 times t is equal to v minus 3 times t plus 1/2. So vt plus 3t is equal to vt plus 1/2 v minus 3t minus 1.5. So this is already looking harder than I thought it would be. So our vt's cancel out. I can add 3t to each side. So I get 6t is equal to 1/2 of v minus 1.5. And maybe I'll multiply everything by 2 here to get rid of my decimals. 12t is equal to v minus 3. So if I want to solve for t, right? So I want to replace my v's with t's. So v is equal to 12t plus 3. So if I plug that in here, I get 12t plus 3 plus 3. So that's 12t plus 6 times t is equal to 90. And so this will give us a quadratic 12t squared plus 6t is equal to 90. And we can subtract 90 from each side to set this equal to 0. I should be able to divide this whole thing by 6. I'll divide each side of my equation by 6. So my right side is still 0. Then I get 2t squared plus t minus 15 is equal to 0. So how do we solve these? We have a quadratic here with a leading coefficient. There's a way to solve these, and I can't remember how it is. And they almost never show up on the Gmat. I can just test things, though. So this is going to be either 2t plus 5 times t minus 3. So I'm just thinking of combinations that are going to give me a negative 15 over here. 2t minus 5, t plus 3, or it could be 2t plus 3 and t minus 5, or it could be 2t plus, or 2t minus 3, t plus 5. So which one of those gets me here? So I need a coefficient of 1 in the middle. So 2t squared minus 6t plus 5t. So that's a negative 1. 2t squared plus 6t minus 5t. So this is my guy. So this is telling me now t is either equal to negative 3 or t is equal to 5 halves. Now, I cannot have a negative time. It doesn't make sense that it took me, I didn't go backwards in time. Couldn't take me negative 3 hours to get somewhere. So this is our only choice for t. T is 2.5 hours. And that was ridiculously long and hard. So A is the answer. I don't know if, I mean, you could try plugging in the answer choices, but then that only would be short if you knew in advance that the answer was A, and then that was the first choice you plugged in. So I don't know. If I, once I felt like I was approaching, 3.5 minutes on this, I would just get out of it. That's how I do it. A.